Science is all about exploring the world around us. We ask questions, make observations, and conduct experiments. Measurements are a fundamental part of this process. But here's the thing, no measurement is perfect. Significant figures help us represent the precision of our measurements. They tell us which digits in a number are reliable and which ones are uncertain. Think of it like this. When you measure something with a ruler, you can only be so precise. Imagine you're measuring a piece of wood for a birdhouse. Your ruler has markings for centimeters, but not millimeters. You might say the wood is about 15 centimeters long. The about is key because you can't be sure if it's exactly 15 centimeters or slightly more or less. Significant figures help us express this uncertainty in a standardized way. They allow scientists all over the world to communicate their findings with clarity and accuracy. So the next time you take a measurement, remember the importance of significant figures. They're not just numbers. They're a language of precision in the world of science. Now that you understand why significant figures are important, let's dive into how to determine them. Don't worry, it's not as complicated as you might think. There are a few simple rules to follow. 1. Non-zero digits are always significant. If you see a number like 3.14, all three digits are significant. 2. Zeros between non-zero digits are significant. For example, in the number 102, all three digits are significant. 3. Leading zeros are never significant. They act as placeholders. So in the number 0.05, only the 5 is significant. 4. Trailing zeros are significant only if the number contains a decimal point. For instance, 100 has only one significant figure, but 100.0 has 4. These rules might seem a bit confusing at first, but with a little practice, they'll become second nature. Remember, the key is to focus on which digits provide meaningful information about the precision of the measurement. Even seasoned scientists can sometimes stumble when it comes to significant figures. Here are a few common mistakes to watch out for. 1. Ignoring significant figures in intermediate calculations. When performing multi-step calculations, it's crucial to carry through all significant figures until the very end. Rounding too early can introduce errors. 2. Confusing significant figures with decimal places. These are two different concepts. Significant figures relate to the precision of the measurement, while decimal places indicate the magnitude. 3. Misinterpreting rounding rules. When rounding numbers, it's important to follow the appropriate rules, such as rounding up if the last digit is 5 or greater. 4. Forgetting about units. Always include appropriate units with your measurements and calculations. Units provide context and are essential for clear communication. By being mindful of these common pitfalls, you can avoid unnecessary errors and ensure that your scientific work is both accurate and reliable. Remember, precision matters. Significant figures aren't just an abstract concept confined to textbooks and laboratories. They have real-world implications in various fields. 1. Pharmaceuticals. When manufacturing medications, even the slightest deviation in dosage can have serious consequences. Significant figures are crucial for ensuring the accurate measurement of ingredients. 2. Engineering. From designing bridges to building airplanes, engineers rely on precise measurements to ensure structural integrity and safety. Significant figures play a vital role in these calculations. 3. Environmental science. Monitoring pollution levels, tracking climate change, and managing natural resources all require accurate measurements. Significant figures help scientists interpret and communicate environmental data effectively. 4. Forensic science. In criminal investigations, even tiny pieces of evidence can be crucial. Significant figures are essential for analyzing trace evidence, such as DNA samples or fingerprints. These examples highlight how significant figures are woven into the fabric of our daily lives, ensuring accuracy and reliability in countless fields. Section 5. The domino effect. How significant figures impact scientific calculations. In the world of science, one calculation often leads to another. Significant figures play a crucial role in ensuring that errors don't propagate through these calculations like a line of dominoes. Imagine you're calculating the density of an object. You measure its mass and volume, each with a certain number of significant figures. When you divide mass by volume to find density, the answer should reflect the precision of your original measurements. If you round too soon or ignore significant figures altogether, your final answer might be inaccurate. This inaccuracy can then ripple through subsequent calculations, leading to flawed conclusions. By adhering to the rules of significant figures, scientists maintain the integrity of their calculations and ensure that their findings are based on solid ground. It's all about building a strong foundation for scientific discovery. Section 6. Beyond the lab. Significant figures in everyday life. You might be surprised to learn that significant figures aren't just for scientists in lab coats. They pop up in everyday life more often than you might think. Think about baking a cake. The recipe might call for 1.5 cups of flour. The significant figures here tell you the precision needed for the measurement. Using 1 cup or 2 cups would significantly alter the outcome of your cake. Or imagine you're following a map. The scale of the map uses significant figures to represent distances accurately. A scale of 1 to 100,000 means that every unit on the map represents 100,000 units in the real world. Even when you're pumping gas into your car, the meter displays the amount of fuel dispensed with a specific number of significant figures, ensuring you're charged accurately. So, the next time you encounter measurements in your daily life, take a moment to appreciate the role of significant figures in ensuring accuracy and precision. In science, we strive for both accuracy and precision in our measurements. While these terms are often used interchangeably, they have distinct meanings. Accuracy refers to how close a measurement is to the true or accepted value. Imagine throwing darts at a bullseye. High accuracy means your darts land close to the center, even if they're spread out. Precision, on the other hand, refers to how close multiple measurements are to each other. Using the dart analogy again, high precision means your darts cluster together, even if they're far from the bullseye. Significant figures help us quantify precision. A measurement with more significant figures indicates greater precision. Both accuracy and precision are essential for reliable scientific results. Uncertainty is an inherent part of any measurement. No matter how precise our instruments or careful our techniques, there will always be some degree of uncertainty in our results. Significant figures help us acknowledge and communicate this uncertainty. The last significant figure in a measurement is always an estimate. For example, if we measure the length of an object to be 10.5 centimeters, the 0.5 is an estimate. The uncertainty in a measurement can arise from various sources, such as limitations of the measuring instrument, environmental factors, or human error. It's essential to recognize and account for uncertainty in scientific work. By understanding and communicating uncertainty, we can interpret scientific findings more accurately and make informed decisions based on data. The precision of our measurements is often limited by the tools we use. Different instruments have different levels of precision, which is reflected in the number of significant figures they can provide. For example, a standard ruler might have markings for millimeters, allowing us to measure lengths to the nearest millimeter. A caliper, on the other hand, is a more precise instrument that can measure lengths to the nearest tenth of a millimeter. When choosing an instrument for a particular measurement, it's essential to consider the level of precision required. Using an instrument that is too precise can be wasteful, while using one that is not precise enough can compromise the accuracy of our results. By understanding the relationship between instruments and significant figures, we can select the appropriate tools for the task at hand and obtain meaningful measurements. Significant figures are more than just a set of rules. They are a fundamental principle that underpins scientific inquiry. By understanding and applying the concepts of significant figures, we can communicate scientific findings with clarity and accuracy, ensure the integrity of our calculations and minimize errors, make informed decisions based on reliable data, advance scientific knowledge through precise and reproducible results. So the next time you encounter significant figures, embrace them as a valuable tool in your scientific endeavors. Remember, precision matters, and every digit counts in the pursuit of scientific truth.